Okay, can you see it?
No, sir.
Can you see the pages?
जी सर देखতে পাচ্ছি
Okay, so we are going to talk about Wilcoxon's rank sum test today. Okay, if you can remember, this is the counterparts of independent samples test. Okay, we studied in our last class that is a Mann-Whitney test, that is independent test, independent samples test. We had two independent samples and we did that Mann-Whitney test. It is non-parametric test. This is also counterpart of two independent samples parametric test. Okay, so if you can also recall that we studied Wilcoxon sign rank test. Okay, so this test is the counterpart of mass pair t-test, Wilcoxon sign rank test. Just get used to that term, that this is Wilcoxon sign rank test. This is the counterpart of mass pair t-test. And we are going to talk about Wilcoxon rank sum test today. Okay, Wilcoxon's rank sum test, and this is counterpart of two independent samples t-test. Okay, this is also equivalent to Mann-Whitney test we studied in our last class. So we are talking about non-parametric test. That is simply when that normality assumptions is violated, samples are small, but non-parametric tests are simple and readily available. But always forget not that these non-parametric tests are less powerful than the parametric tests. So when you have a scope that your data set is at least approximately following normal distribution, then you have to use those parametric tests you learned. But when you have no other option, you don't have any opportunity to have that normality assumptions fulfilled, then you have to use these non-parametric tests when applicable. And when you have two independent samples, you can use that Mann-Whitney test in non-parametric test. This is also another way that Wilcoxon's rank sum test. This is equivalent to Mann-Whitney test. It says, suppose that n observations are available from the first population, n observations from the second. The two samples are pooled like Mann-Whitney test. You have to consider as if they are coming from the same sample. So we have n1 plus n2 observations. Then we rank them in ascending order. You can do that descending order too, no problem. With tie is assigned to the average of the next available ranks. That is, you have to attribute the ties observation to the average of the score, as we did in our last class. Let T denote the sum of ranks of the observations from the first population, and R2 can be and R1 can be for the Mann-Whitney test, যেরকম আগের ক্লাসে ছিল. This T is equivalent to R1 in Mann-Whitney test. Assuming that the null hypothesis be true, the Wilcoxon's rank sum test statistic T has that expected value of T equals n1 into n1 plus n2 plus 1 by 2. This is the mu T, and sigma T square is n1 into n2 into n1 plus n2 plus 1 by 12. So for large sample, at least 10, that Z equals T minus expect mu of T divided by sigma T. It has approximate normal distribution. So then you can compare that. Then you can compare that with normal distribution tabulated value, say 1.96 at 5%, whether your null hypothesis that the two medians are identical against the alternative hypothesis that the two medians are different based on this Wilcoxon sign rank test. This is a snapshot of SPSS, IBM SPSS package program. Okay, how you can do that two independent sample test using those SPSS package program. Okay, if you see that Mann-Whitney test is here, Kolmogorov-Smirnov Z test is here, so you can do that with a single click by using this SPSS package program. This is just an idea that you can analyze all the tests you learn with a single click using this software IBM SPSS. This is known as simply SPSS. Okay, so we here in this course, our goal is to calculate all these tests and make decisions for your problem using calculator, using manual calculation with smaller data, so that you can calculate that manually with your calculator. So we did that. This Wilcoxon rank sum test is the same, exactly the same thing in Mann-Whitney test we studied in our last class. So we are not going to repeat that here. So in our last class, you solve this problem and you were able to make conclusions based on this statistic. So one thing I want to tell you that you take notes on these variety of non-parametric tests. We study chi-square test, that is chi-square test of goodness of fit. We study sign test, that is equivalent to proportion test in parametric test. Wilcoxon sign rank test, it is equivalent to mass pair T test. Mann-Whitney test, it is equivalent to independent samples T test. We are studying here today Wilcoxon's rank sum test. It is also equivalent to independent samples T test. So these were the non-parametric tests we learn. Okay, Our next topic is Kruskal-Wallis test. The Kruskal-Wallis test is equivalent to the one-way between groups ANOVA. Okay, আমরা এর আগে ANOVA পড়েছি parametric test-এ, where our null hypothesis was whether several means are equal. Okay, more than two means are equal against the alternative hypothesis that they are not equal. At least two of them are not equal. So Kruskal-Wallis test is equivalent to ANOVA. Okay, so here what we are going to test in non-parametric test, if we have more than two groups to compare, then we have to use Kruskal-Wallis test. Okay, that means we are going to test that more than, say, three groups medians are equal. Okay, are identical, not equal. We had in non-parametric test we want to say that they are identical. Okay, and against the alternative hypothesis, against the null hypothesis is that they are different. At least two of them are different. So that is the Kruskal-Wallis test we have. For example, suppose an educational psychologist is interested in determining the effectiveness of three different methods of instruction for the basic principles of arithmetic. A total of 27 primary grade children were randomly assigned to the three methods of instruction conditions. You see, this is A method, B method, and C method. The scores recorded in the following are the number of correct answers obtained following completion of their instruction. So this S1, S2 are student number. We have 27 students, and their instruction score is like this: 4, 5, 4, 3, and so on. So we want to compare whether the median of these three instruction methods are identical. Okay, so that is we are going to compare. So for doing that, this sort of testing for more than two groups, okay, more than two groups, it can be three. So 3 is the simplest one. It can be 4, 5, and so on, any number of groups. So this Kruskal-Wallis test, what we need NI, I equals 1 to k, be the number of observations in the ith sample. Okay, so learn that accordingly. Here we have three groups. Okay, A group এর মধ্যে 9টা নাম্বার আছে, 9 scores. Okay, so we have n1 equals 9, n2 equals 9, n3 equals 9, I equals 1 to 3. Okay, k equals 3. So first we compare all the sample values and arrange the n equals n1 plus n2 plus n3 observations in ascending order. Okay, আমাদের এখানে যে 27 আইটেম আছে এদেরকে ascending order-এ সাজাতে হবে, ছোট থেকে বড়, considering the three groups are the same. Okay, তাহলে 27 observation-কে ascending order-এ আপনাদেরকে সাজাতে হবে. In the case of ties, we follow the usual procedure of replacing the observation by the means of the ranks that the observation would have. Okay, আগের দিনের মতো যে যদি দুইটা অবজারভেশনের টাই হয় তাহলে তাদের সাকসেসিভ দুইটা র্যাঙ্ক এভারেজ করে দুইটাকে দিতে হবে। যদি তিনটা অবজারভেশন র্যাঙ্ক হয় তিনটাকে এভারেজ করে প্রত্যেকটার জন্য সেম র্যাঙ্ক হবে। The sums of the ranks corresponding to the NI observation in the ith sample is denoted by the random variable Ri. Okay, so Ri will have values R1, R2, R3, as we have 3 groups here. So those are the sums of the ranks corresponding to the Ni observation. Okay, আগের দিনের মতোই যে 4 এর র্যাঙ্ক, 5 এর র্যাঙ্ক, 4 এর র্যাঙ্ক, 3 এর র্যাঙ্ক, এই র্যাঙ্কগুলো যোগ হয়ে সেটা হবে R1। এই ভ্যালুগুলো যখন আপনি র্যাঙ্ক করবেন তাদের ভ্যালুগুলোর সাম হবে R2, R3, আগের দিনের মতো। ওকে, now let us consider the Kruskal-Wallis test statistic, that is Hayes equals 12 divided by n into n plus 1 summation of I equals 1 to k। এখানে আমাদের example এর জন্য 3 হবে, as we have 3 groups here। Ri square divided by ni minus 3 into n plus 1। So this is the Kruskal-Wallis test statistic, so we have to calculate this Hayes based on the ranks of the observation we actually will produce from those numerical examples. This is has an approximate very well by chi-square distribution with k minus 1 degrees of freedom. So we have 3, k equals 3, to 3 minus 1, 2 degrees of freedom হবে আমাদের when null hypothesis is true, and if that is sample consists of at least 5 observations, so that is the condition for chi-square distribution. So this value of Hayes will be compared to the chi-square tabulated value, whether your null hypothesis would be rejected or not. Okay, so this is as before man-Whitney U-test. So you have to see whether this Hayes calculated value is greater than chi-square tabulated value for 2 degrees of freedom. Then if it is greater than that chi-square tabulated values, then your null hypothesis would be rejected. What was your null hypothesis? That the 3 instruction methods, the median of the 3 instruction method scores are identical. It is your null hypothesis. Alternative hypothesis that they are different. Okay, so if your Hayes calculated value is greater than that chi-square value, the null hypothesis would be rejected. That is, they are different. Okay, so based on that you have to make decisions. So grab some pen and paper and find the ranks of this example and then find Ri. Before that just write down the value of this Hayes. Okay, এই ফর্মুলাটাকে লিখে নেন, এরপরে আমরা ডেটা পেজে চলে যাব। Okay, then come to this example. এখান থেকে এখন আপনারা যে Ri এর কথা বলছি আমরা, Ri is the rank of the individual group, ith group। যে এখানে যে 27 ডেটা আছে, আগে ডেটাটা তুলে নেন এবং ডেটা তুলেই আপনারা কি করবেন, যখন এটা সলভ করবেন সব সময় আপনি প্রথমে গ্রুপ লিখবেন a b c এবং গ্রুপের পাশেই আর একটা কলাম তৈরি করবেন। ওকে, গ্রুপের পাশে একটা কলাম তৈরি করবেন এবং সেখানে আপনি র্যাঙ্কগুলো বসাবেন। ওকে, আপনারা দেখতেই পাচ্ছেন যে ফার্স্ট অবজারভেশনটা 1, তাই না? 1 কয়টা আছে? 1 দুইটা আছে, কাজেই 1 এবং এই 1 এদের র্যাঙ্ক হবে 1.5 1.5। ওকে, কাজে এটা দিয়ে শুরু করেন এবং আমাকে বলেন যে RI কত হবে। কেউ কোথাও আটকালে সঙ্গে সঙ্গে কোশ্চেন করবেন। R1 R2 এবং R3 এর ভ্যালু যাদের ক্যালকুলেশন হয়ে যাবে আর চ্যাট বক্সে লিখবেন। ওকে, কারো ক্যালকুলেশন হলো? বলেন R1 এর মান কত, R2 এর মান কত বলেন, R3 এর মান যাদের ক্যালকুলেশন হয়েছে চ্যাট বক্সে লিখেন so that you can compare and you are not doing wrong. Okay, if you write that and compare with others, that is the only way you can make sure that you are not doing wrong. Okay, so when you are done with the calculation of R1 R2 R3, write in chat box. বলেন তাহলে কেউ যে R1 এর মান কত? এতক্ষণ তো লাগার কথা না। কোনো সমস্যা হলে কোশ্চেন করতে হবে। ওকে, কারো হয়নি এখনো? আপনারা বলেন যে R1 এর মান কত, R2 এর মান কত, R3 এর মান কত? এখান থেকে দেখেন n এর মান কত পেলেন, সেগুলা রাইট হ্যান্ড সাইডে বসিয়ে h এর মান কত পেলেন, and that h will be following chi-square distribution with 2 degrees of freedom. So that is you have to compare with chi-square tabulated values. If I help you with the chi-square tabulated values with 2 degrees of freedom and with 0.5 alpha, that value is 5.991. So just take notes that chi-square value is 5.991 with 2 degrees of freedom. So when you are done with calculation of chi-square, that is h, you have to compare that value with this chi-square tabulated value 5.911. So tell me what is the value of h now. If you face any problem with any of this item calculation, just raise your hand. সাদমিন বলেন R1 এর মান কত পেলেন? হ্যালো, আপনারা কি শুনতে পাচ্ছেন আমাকে?
জি স্যার, শুনতে পাচ্ছি।
হ্যাঁ, N1 এর মান কত পেলেন?
স্যার আমি ক্লাসে দেরি করে আসি কোশ্চেন দেওয়ার আগে।
ওকে, সাদমিন বলেন যে আপনি R1 এর মান কত পেলেন? রাফাতুল R1 এর মান কত পেলেন? R1 এর মান কত পেলেন রাফাতুল? বের করতে পেরেছেন কিনা? ওকে, অন্যরাও কি বের করতে পারেননি? কোনো সমস্যা হলে কোথাও আটকে গেলে কোশ্চেন করতে হবে তো। কোথায় আটকেছেন বলেন, নাকি মানে করতে দেরি হচ্ছে? র্যাঙ্ক গুলো বসাতে দেরি হচ্ছে, নাকি কোথাও আটকে গেছেন? এতক্ষণ তো লাগার কথা না। কোথাও আটকে গেলে সেটা তো বলতে হবে যে কোথায় আটকেছেন। নিউমেরিক্যাল এক্সাম্পল পরীক্ষায় থাকবে, কাজেই এগুলোর সাথে আপনাদের ইউজড হতে হবে। এবং আরো ইন্টারেস্টিং হচ্ছে যে এক্সামের যে দুইটা পার্ট থাকে, ইউজুয়ালি থিওরিটিক্যাল পার্ট এন্ড এটার একটা নিউমেরিক্যাল পার্ট। তো নিউমেরিক্যাল পার্টের মার্কটাও মানে ফুল পাওয়া যায়, কাজেই আপনাকে ক্যালকুলেশনে খুব ইফেক্টিভ হতে হবে। ওকে, R1 এসেছে 114.5 তানজিম বলছে, কাজেই অন্যরা বলেন। তানজিম R2 এর মান বসান, R3 এর মান বসান। আমরা উপরে যেরকমটা বলেছি যে প্রত্যেকটা ভ্যালু এখানে রাইট হ্যান্ড সাইডে, এই যে রাইট হ্যান্ড সাইডে যে এক্সপ্রেশন গুলো আছে, so that I get an idea that you know all these items you have to calculate. Okay, R1, R2, R3, good. Then N1, N2, N3. N1, N2, N3, fine. No, you have to write the formula first there. Okay, সবখানেই আপনি ফর্মুলা না লিখলে কি হবে যে you maybe some people want to copy from others, so that is an indication. So if you want to get the highest grade, then you must write that formula first and show all the calculations. Okay, okay, তানজিম লিখেন যে n এর মান কত? N27. সো এখন অন্যরা বলেন যে আপনাদের R1 কত হলো, R2 কত হলো, R3 কত হলো, so that we can tell you whether you are right or wrong. Shahabuddin has come the value of R1, R2, what is the value of R2? Shahabuddin, R2 এর ভ্যালু কত পেলেন বলেন? R3 এর মান বলেন? Okay, Alhamdulillah, let's come with the values of R1, R2, R3 and Rn. Okay, so we got these values very similar, exactly the same, so this is fine. So tell me the value of H now. Tanjim, the value of H is 9.7. Okay, so other people, Mahmudul, Shahabuddin বলেন যে H এর মান কত? Okay, those who are ready, we got H equals 9.79. Okay, 9.79. So this is good that we got H equals 9.7 and we got chi-square tabulated value 5.99. So you know that your null hypothesis can be rejected as your value for H is greater than the tabulated value of chi-square with 2 degrees of freedom. Okay, so based on this problem, we decided that the 3 instruction methods are different. Okay, they are not identical. So based on this problem, we decided that based on our Kruskal-Wallis testing, that the 3 instruction methods are different. They are not identical. Okay, so this was the this was the last topic of our non-parametric test chapter today. So do you have any other question? So if you don't have any other questions, then this is the end of today's class.